Greetings everyone and welcome to the fifth video in this 10 video series. My name is Vyom Khanna and I'm delighted to be with you. In the previous video, I hope you learned a great deal about the Internet of Things and its relation to your daily lives. Over the following 10 videos, we will delve deep into concepts like Arduino coding, initializing sensors, soldering, Node MCU, and their real-life applications. Today, we are on the fifth video in the series, so let's keep pushing for success. This video will delve deep into examples of Arduino code and what that code means from a practical standpoint. We explored the intricacies of the Arduino IDE and ended the last video with a discussion on all the tools available for programmers. Now that we've built our base and are familiar with the IDE, let's get right into the coding aspect. This video will showcase how you can exploit the Arduino IDE to write fantastic and exciting code. So let's get onwards right away. Before we get started though, you need to know that Arduino coding is based on the C language. Still, there are unique additions and inbuilt libraries to deal with the external hardware like microcontrollers, sensors, etc. In Arduino, much like other leading programming platforms, there are libraries, which are basically storehouses of code that provide immense functionality. These libraries can be imported to enhance Arduino's capabilities and features. These libraries either interact with a specific component of the microcontroller or provide a variety of new functions which can be implemented. But how do you import these libraries? To import a new library, you need to go to Sketch and click the Import Library button. Examples of valuable libraries are Liquid Crystal, DHT Sensor, and NeoPixel. All Arduino programs have the same basic overlying structure. They are divided into two major parts: the setup segment and the loop segment. But what does this even mean? Well, let's get started with the setup segment. When a code segment's execution starts, the setup function is called. Use it to initialize variables, pin modes, libraries, etc. The setup function will only run once after each power-up or reset of the Arduino board. It handles the prerequisites and sets everything up for the main functionality of the program to occur. Any code that lives inside the setup function's curly brackets runs once at the very beginning of your program and then never again. At least not until you reset the Arduino or upload new code. The main functionality though occurs in the loop segment. Like the setup line before it, this is another required Arduino sketch function. While the setup function sets your Arduino up, the loop function, well, it just loops. This is where the bulk of your Arduino sketch is located. The program starts directly after the opening curly bracket and runs until it sees the closing curly bracket, jumps back into the first line of the loop and starts all over repeatedly until you disconnect the wire. The loop function will run over and over until the Arduino is reset. You must understand the nature of both functions to decide where you want your lines of code to be placed. Some code belongs in the setup section and some code belongs in the loop section. It is your job to decide which code belongs where. Another significant concept in Arduino coding is the subject of time. Time is essential for Arduino programs. You need to specify the time period and frequency of the sensors at various points, and you can even coordinate the rate at which information is sent back and forth. The time factor is mainly used in the loop section of the program and even determines the period of each successive loop. The time in Arduino programming is measured in milliseconds, where 1 second equals 1000 milliseconds. And we have to adjust the timing based on milliseconds. So, for a 5-second delay, the time displayed will be 5000 milliseconds. Don't worry, it seems confusing right now, but it'll get simpler once we reach it. As we move forward with this video, we will reach a point where we look at an example which involves the use of time, so your concepts will be crystal clear by then. Now that you've got a basic idea about the structure of an Arduino program, let's get right into an example. So, we are now going to discuss the blink example, which is as simple as it sounds. We simply make an LED blink repeatedly. Before we get started, you should know that you can open this example yourself on the Arduino IDE. First, click on the File button, which is present on the menu bar. Then, click on Examples. Finally, click on the Basics option and click on the Blink program. The example will reopen in a new window, as shown below. Now, let's examine this example deeply. The void setup section includes pin mode as the main function. Pin mode is a new and very important function, so let's see what it actually does. Well, it acts directly on the specified pin number and initializes it as either input or output. The syntax is pin mode, brackets pin, mode, followed by brackets containing the pin number and the mode separated by commas. Reiterating, the pin here is the pin number. We can select the pin number according to our requirements. Note though that the pin number depends on the microcontroller. Now, moving on to the mode. We can set the mode as input or output according to the corresponding pin number. Let's understand the pin mode with an example. So, suppose we want to set the pin number 12 as the output pin. We write the following code. Pin mode, the bracket starts, 12, output, and bracket closes. But make sure that you put a semicolon in the end, as it is with all major programming languages. A semicolon is required to distinguish the end of a line of code. It is usually recommended that you activate the pin mode by setting it up as output. But why do we do this? Well, the output mode of a specific pin number provides a considerable amount of current to other circuits, which is enough to run a sensor or to light the LED brightly. You should also know that the output state of a pin is considered the low impedance state. The high current and short circuit of a pin can damage the microcontroller chips, so it is recommended to set the mode as output. Don't worry though, setting pins to input mode also has advantages. We can use the input mode to use external pull-down resistors and much more. But as of now, the output version will be used mostly because we want the pin to perform a certain action. A pin on input mode can weirdly power an LED, but only if we use the pull-up mode. A sufficient amount of current is provided by the pull-up mode to dimly light an LED, which is connected to the pin in the input mode. If the LED is working dimly, it means the condition is working out. Still though, it is recommended to set the pin in output mode. Moving on, the void loop includes a digital write and delay as the main functions. Digital write is another important function which we must consider. The digital write function is used to set the value of a pin as high or low. When we choose the high option, it sets the value of the voltage to either 5 volts or 3.3 volts, depending on the microcontroller. For low, it sets the voltage to 0, which is the ground state. If we do not set the pin mode as output, the LED will light dimly. The syntax for the function is digital write, bracket open, pin, which is followed by a comma, and then the value, which can either be high or low. Let's understand this with an example. Carefully examine both of these lines of code and try to figure out what they do. The first one will turn the LED on, and the second one will turn the LED off. But do remember that it will be the LED which is connected to pin number 13 in both cases. What is the difference between the digital write and the digital read function? Well, the digital read function will read the high or low value from the digital pin while the digital write function is used to set the high or low value of the digital pin. Basically, one will tell you the status of the pin, while the other will actually change the status of the pin. Moving on to the next function, we have the delay function. The delay function is a blocking function that pauses the program from doing a task during the specified duration in milliseconds. For example, delay 2000. Remember that 1 second is equal to 1000 milliseconds. Hence, the above line of code will provide a delay of 2 seconds, not 2000. Now, look at these 4 lines of code. This constitutes the bulk of the program, so I'm going to leave you with a few seconds to try to understand what's going on before explaining it to you. Here, the LED connected to pin number 13 will be on for 2 seconds and off for 1 second. The task will repeatedly execute as it is in the void loop. Although it may be hard to realize that you have already created a blink function, that is exactly what you have just done. It's truly as simple as that. The LED connected to pin number 13 will first turn on for 2 seconds and then it will turn off for 1 second, repeatedly until you disconnect the board or terminate the program. This just goes on to show how truly powerful Arduino code is. With just 4 lines of code, you've created a fully operational blink function. Congratulations! Before we finish with this concept, let me show you the circuit diagram so you can do this whenever you want, as long as you have the parts. You will require a power source, an Arduino Uno, 2 male-to-male jumper wires, a breadboard, a simple 2-pronged LED, and lastly, a resistor. Before you complete your coding for this simple project, you will need to set up the circuit first. So let me give you instructions about that. Take an Arduino Uno and connect it to your computer using the USB cable. Next, take the simple LED. LED is the abbreviation of the light emitting diode. It is usually made of gallium arsenide or gallium phosphide, which are semiconductor materials. The LED has 2 electrodes, a positive electrode and a negative one. It lights up only when a forward current passes, and it can flash red, blue, green, yellow, etc. The color of the light depends on the material it is made from. In general, the drive current for an LED is 5 to 20 milliamperes. That is why it usually needs an extra resistor for the current limitation to prevent damage to the circuit. Keep in mind that both of its 2 pins are different, and if you connect the wrong jumper wire to one, then the project will not work. Plug the resistor and then the LED directly into the breadboard by just pushing its metal pins inside until fixed. Make sure they are positioned exactly as in the image, one directly above the other. When done, take 2 jumper wires of different colors and connect them to the ground or GND and pin number 13 of the Arduino Uno. Then, connect the GND jumper wire to the straight pin of the LED, not the one with the pre-existing bend, or it will not work. This bend is used to show which electrode of the LED is positive and which is negative. Connect the pin 13 jumper wire to the hole just below the opposite end of the resistor as shown in the diagram. Check to make sure the circuit is correct. Then upload your code onto the Arduino Uno. Hopefully, it should work. If it doesn't, then you most likely need to reverse the positioning of the LED electrodes. If it still doesn't work, there must be another factor at play. So debug both your circuit and your code and start from scratch if you are missing the mistake. Congrats on your first circuit. I have to admit though, that all of this could have been done much easier without any wiring or even any resistor. Look at the diagram on the screen right now. Don't worry, even though you made a more complicated circuit, it was the better idea, as you will now be more comfortable when working with breadboards and wires. Only if you move out of your comfort zone will you truly make progress. So I hope you had fun with this video and see you next time.